The ACES Christmas tree is made up of small LEDs powered in series, and those rows are connected to different pins in a 460 IC. However, the star on top is different. This component can change color on its own when given power. This circuit can be powered in two ways. The first way is when the two compression springs are connected to a 9-volt battery that sits in the base. The second is to connect a 9-volt AC/DC adapter to the kinked power jack on the side of the tree. The final product is an amazing gift for Christmas. To make this tree, multiple prototypes had to be built in order for us to learn how to make this. The first part of this project is to build an RC oscillator using NAND and inverter gates. Inverter gates work by taking input and giving the opposite effect for the output. In this circuit, the first inverter is connected to ground or low. Then the inverter takes this low and makes it high, or power. The NAND gives low when both are on, and the reverse is as said before. When the circuit is given power, the NAND gate have one high and one low input. Because of this, the output will be high. Current will then flow through the two inverter gates, in turn turning the flow twice from low and back to high again. In this scenario, the LED will be connected to low and high, turning it on. Current will also flow from the output of the NAND and through the 47K resistor to the capacitor, charging it up. When it finishes charging, it will discharge through the 330K resistor to the input of the NAND. This means that both inputs of the NAND will be high, making the output low. The inverters will change that to a high and back to low. Since the LED is only given lows, it will stay off. When the capacitor finishes charging, it will restart the process and the square wave is achieved. The 460 frequency divider is the second part of this project. It works similarly to the first part with a few differences. The first difference is the NAND and inverter gates have been replaced by a 460 IC. This IC produces the same as the three inverter gates and the NAND gate, except it can produce multiple different square waves with different frequencies from different pins instead of just one, like with the inverters and NAND gate. It does still need the two resistors and capacitor to work though. The frequency of the circuit can be found using these equations. The equation 1 over 2 times R1 times C can be used where R1 represents the 47K resistor and C represents the capacitor. To find a specific frequency of a pin, all you need to do is just divide the answer of the first equation by 2 to the power of Q, where Q represents the number pin being used. The final difference is the RGB LED. This LED has 3 of its pins connected to the 460 IC. Each one receives a different frequency, making it show colors in a way that resembles counting in binary. This means red represents 1, green represents 2, and blue represents 4. Because of this, the circuit can count to 7. The multiple LED circuit is quite similar to the previous circuit, where both have the 460 IC and the same resistor capacitor setup. The LEDs are the difference. Within the circuit, with this circuit using multiple LEDs set up in series instead of just the RGB LED. Although it still counts just like the other circuit, each row of LEDs is connected to a different pin, from Q4 to Q7. When the pin outputs low, the LEDs connected to power turn on, and when the pin outputs high, the LEDs connected to ground turn on. Like the other circuit, this circuit can count with the first row representing 1, the second representing 2, the third representing 4, and the fourth 8. This means that the circuit can count up to 15.